probably you have heard about the Industry 4.0,
Sure. Yes.
which basically aims to connect every single device that
Yes.
exists in manufacturing, let's say, industry, with the aim of creating digital replicas or digital twins of their machines, their equipment,
Yes.
and then being able to look at how those machines perform today and also how they could perform in the future. And I think that's some of those concepts are being taken in the energy sector. We are seeing that current research projects aim to bring these notions of digital twins for power grids, which will enable potentially to make a better operation of the system as it exists, especially in the event of volatile and uncontrollable resources. By volatile and uncontrollable resources, I refer to renewable energy such as wind power or solar energy. And I think those are some of the challenges on bringing this kind of digitalization up to a level that can be used during operations, that can bring this idea of smartness or intelligence, which is normally confused or understood as the capacity to forecast better the future and provide better insights.
Yes.
And I think we're going to see a future in which by having this digitalization, we're going to enable some intelligence in the digital world not ever seen before. And I imagine a future, if I have to say, so I imagine a future where the problem will not be about digitalizing all our infrastructure and facilitating connectivity and making it smart itself, but will be more about looking at what point in time we have to leave decisions to this digital, let's say, version of the reality, and at what time does human enter into the picture.
Right.
And I think that's what makes it really difficult to know what the future is going to look like.
Right.
Because it could become a really apocalyptic picture easily, as well
Right.
as it can become a really, let's say, big solution to many of the problems we have
Yeah.
in relation to the complexity of integrating uncontrollable resources, of having multiple technologies, of having multiple people thinking about it, or multiple people consuming at different rates in different locations, and new devices, new also ways of consumption that we try to decrease. Also, but the rebound effects that come up with consumption that we don't know too much about them. There is this so known paradox called the Jevons paradox. Maybe you have heard about that.
Yes.
Which basically just tells that the more you make efficient a system, the more you actually, instead of reducing consumption, it increases it, right?
Yes.
And we see it with vehicles, transportation. That's a normal example of making bigger highways.
Yes. And more congestion because of that.
Exactly, more people, just to reduce congestion, but at the end, just more people enables more people to use certain
Exactly,
resource. And I think a lot of the initiatives we see in the energy sector is to opt for energy efficiency in buildings, in transportation, as a response to offset a little bit the picture of use of fossil fuels, but also of the emissions related to current patterns of consumption. And there will be a point in which we need to see how we can constrain that efficiency that we provide to energy systems or to consumers to a level that they don't consume any more than is expected for the sake of having a sustainable consumption of energy resources. And why I'm talking about these different points, I think they can come at different, let's say, can come separately or together. And I will say that all those questions will come together into a future, into the tipping point of who decides whether we should do energy efficient systems, or we should focus on integrating more renewable energy sources. And probably those decisions in the future will not be human based, but will be algorithms or computer programs which will do that. And I can see that happening at a certain point. There will be just the perhaps the disruption in the timeline of where things are going to be
Right.
moving on.